Okay, so we got a couple theorems left in this unit, and the first one we can fill in number 51, actually. So number 51, there's this theorem described there called the triangle angle bisector theorem. And it states that if you have an angle of a triangle that's bisected, so cut in half, and in this case, we'll make it this angle down here, because that's the one that looks like it's bisected, then the bisector, whoop, hold on, this thing right here, divides the opposite side, which is this, into segments, one segment, two segments, that are proportional to the other two sides of the triangle, this one and this one. Okay. So I think this is easier seen if we assign letters for the side lengths. So let's do that. So I will call the sides of the triangle next to the bisector, I'll call it A and B. And then I'll call this third side that got cut up by the bisector, C and D. And so really all it means is that since it's cut up proportional to the other two sides, that if you make a proportion out of this side, C over D, right? C over D, that's the same thing as A over B. Um, some students prefer to put the A over B in front and then C over D in as the second one. Doesn't matter to me. Another way of setting this up, actually, is this. Uh, if it's a little bit different setup, but the cross multiplication works out the same. You could go A over C equals B over D as well, right? It's almost like if you're looking for a way to like a little trick to sort of remember what you're doing here, you're starting at the bisector where the angle gets bisected, and then you go out from it and back in, right? Out and back in. It's kind of like that up-down theorem that we talked about the other day, but this one's more like out and in, right? So A over C equals B over D. All right, and this is actually the one that I tend to remember. They don't quite say the same thing, but when you cross multiply, if you look at the next step, it would be A times D equals B times C, A times D equals B times C. So they're equivalent statements. The outcome is the same. Okay. So let's try it with number 51A down here. Okay, here's our angle bisector down there. This side's 15, this side's X, this is 18, and the whole thing is 32. So if the whole thing's 32 and one part is 18, then the left over here is 32 minus 18, which is 14. And then if we use that idea going out, coming back in, 15 over 14 equals x over 18. That's using the triangle angle bisector theorem. Or alternatively, you could have set up the 15 goes with the x the way the 14 goes with the 18. Both are valid. I'm not going to be picky which one you choose. Um, One thing to note though, the triangles themselves, the two little triangles, they're not similar, right? They don't have to be. Uh, the reason this is in this unit is because of the proportion idea. And if we were to prove this theorem, we'd actually we'd sort of extend some lines and create some similar triangles out of it. So similarities involved, but in the diagrams that we're given here, the little triangles are not similar to one another. They only have one angle in common, and you can't match up anything else in there. Not the way that we've been doing our proofs, right? So let's take this one, 14 over 18. The reason I wanted to take this one is because 14 over 18 could be reduced to 7 over 9. And then that makes the cross multiplication a little bit easier, although it wouldn't matter if you were using a calculator anyway. So if we cross multiply, 15 times 9 is 135, and then we get 7x on the other side. And so if I do both sides divided by 7, then I'll just get x equals 135 over 7. In the other diagram, same sort of deal. I got a 9 and a 7 coming out. And then coming back in, I've got this segment and an x. The whole thing's 11, so that means this leftover part is 11 minus the x part. So now what I'm going to do is set up our proportions. If we wanted to do that going out and coming back in from the angle bisector, it'd be 9 over 11 minus x equals 7 over x. Or you could also set up 9 over 7 equals 11 minus x over x. Either one is okay. Doesn't matter to me which one we pick because the cross multiplication step's the same for both. So in either case, we'll get 9x equals 7 times 11 minus x. So 9x equals 77 minus 7x. So then if we add the 7x over, it's 16x equals 77. So x ends up being 77 divided by 16. Right there. Okay. All right. Let's scroll down a little bit. So that's how the triangle angle bisector theorem works. Okay. It won't show up in a proof. I'm not going to throw that one at you in a proof. It's really more solving for X type problems that you should be kind of be on the lookout for these. Okay, so let's take a look at this other theorem down here. This one involves 3 parallel lines and 2 transversals. And it says that if you have 3 parallel lines and they intersect 2 transversals, then the transversals are cut up proportionally. So what that means is that the way that these transversals cut up the way that these parallel lines cut up one transversal, A to B, it cuts up the other one in the same proportion, C to D, right there. So you can set up the equation A over B equals C over D. Okay. There is an alternative too. You could also set up A goes with C the way that B goes with D. And that would be suitable too. Let's see, what else here? Either way, the cross multiplying step is going to be the same. In both cases, you get A times D equals B times C. In this second one, though, you notice we're doing like stuff from the left over stuff from the right. A over C, B over D. So you can actually equate that with E over F as well. The way that I've proven this with students in the past is actually to just take this line and slide it over to here, right? You don't change the slant of it, so it actually, you're making a parallel line. So this forces this shape to be a parallelogram and this shape to be a parallelogram, which means that this side would be C and this side would be D, and this length here would be F. And we figured out the other day in class that if you have a triangle with a parallel line cutting through it, then you can set up ratios like this over this equals this over that, right? We did a whole bunch of them. If you look at, I think it was number 50 in the handout. So this is directly related to that idea there. Okay. All right. So I hope that helps. And these should pop up in the next homework assignment and probably in the review that's going to be coming up pretty soon before your test. Your test, I think, week from Thursday. So, okay, I hope that helps some, and I hope to see you soon. All right, take care. Bye bye.